Welcome to this explainer. Listen, if you have ever found yourself just staring at a totally vague bug report, trying to solve what feels like a complete mystery, you are in the exact right place. Today, we're going to act as digital forensic investigators. Using a simple JavaScript sandbox project right on the Sentry free tier, we'll see exactly how to solve these mysteries using the data your app is already collecting. Let's get into it.
Okay, look at this. The app crashed. Fix it. Oh man, we have all received this dreaded, zero-detailed support ticket, right? It is universally frustrating for developers and support engineers alike, mostly because it gives you absolutely nothing to go on. It's like being told to find a needle in a haystack, but you aren't even sure if it's a needle you're looking for.
Normally, a ticket like this feels like a total dead end. Zero details basically means zero direction. But actually, here is the secret. Sentry already recorded everything. Today, we are transitioning from reactive guesswork to proactive forensics, because all that digital evidence you need, it's already captured, just waiting for you to look at it.
Okay, let's dive into key point 1, Sentry breadcrumbs and the event trail.
So what exactly is a breadcrumb? Well, think of it as a highly structured event record. Unlike your traditional messy server logs, breadcrumbs document the exact state changes and interactions leading right up to an application failure. It is essentially the chronological timeline of your user's journey, right up to the very moment everything broke.
Check out how this timeline completely reconstructs the scene for us. In our JavaScript environment, the browser SDK is literally monitoring the document object model. 3 seconds ago, the user viewed the cart. 2 seconds ago, they clicked pay. 1 second ago, an HTTP request fired. And then, bam, the crash. We aren't guessing what they clicked. The SDK literally rebuilt their path step by step.
The best part? Right out of the box, the SDK automatically captures HTTP requests, DOM clicks, and UI navigation. But you can also enrich this trail manually. You can capture specific business logic, like cart modifications, using the Add Breadcrumb API. And hey, if you're worried about privacy, no problem. You can easily scrub personally identifiable information using the Before Breadcrumb hook, which keeps your data totally secure and compliant.
Moving right along to key point 2, user context, or figuring out exactly who experienced the bug.
When a crash happens, you really need to know who got hit. Using the User API, Sentry bundles a persistent identity with every single event. So, looking at the payload, we instantly get the user's email, their unique internal ID, and their IP address. It's all right there.
Now, this totally changes how you investigate. The old way was just this vague search, scrolling through endless generic errors, hoping to spot some sort of pattern. But the forensic way, that's a precision search. By typing user.email@vipcustomer@example.com into the Sentry search bar, engineers can instantly isolate the exact session and events experienced by that specific reporting user. It's a total game changer.
Next up, key point 3, release tracking. This is where we find the weapon.
Through release orchestration, we unlock one of Sentry's absolute best features, the suspect commit. Sentry defines a suspect commit as the specific code change and the individual developer identified as responsible for introducing an error. By simply tagging your deployments with a git commit SHA or a semantic version number, you make code-level accountability fully automated.
And this brilliantly illustrates why Sentry's code mappings are so incredibly powerful. Normally, a minified stack trace just points to line 42 of some checkout script, which, let's be honest, is not very helpful. But with repository integration, Sentry maps that frame it directly to version control. So instead of a vague file path, we immediately see that Jane Doe introduced this bug in commit DA39A3E.
All right, key point 4, environment filtering. Let's talk about establishing an alibi.
Listen, alert fatigue is a massive operational risk. If your dashboards are just polluted with staging noise, say 80 staging errors completely drowning out 20 critical production errors, your team is definitely going to start ignoring notifications, and we do not want that.
By just passing a simple environment tag during SDK initialization, you completely segregate these streams. A staging environment error, that can be routed for a low-urgency Slack channel review during normal business hours. Meanwhile, a production environment error instantly triggers a high-urgency PagerDuty alert. This ensures your support teams only get paged for issues that are genuinely impacting your end users.
Section 5. Let's look at a real support scenario and solve a mystery.
Okay, let's put all of this together.
A VIP customer just reported getting a white screen on checkout in our JavaScript application. Zero details other than it broke. So, what does this all mean? How do we escalate a precise root cause for this completely blank ticket in under 5 minutes? Let's run the playbook.
We're going to run a super fast 4-step diagnostic funnel. First, we filter the issue stream by the user's email. Second, we read the chronological breadcrumb trail to see their exact clicks. Third, we check the release version to see if this is tied to a new deploy. And fourth, we identify and escalate that suspect commit.
Opening up the issue, let's read the digital evidence. 1 minute ago, the VIP viewed the cart. 45 seconds ago, they clicked pay. The SDK loaded, and then 43 seconds ago, boom, the crash happened. Undefined is not a function. Notice how we didn't even have to ask the customer to reproduce the bug? The exact path of the crash is literally right here.
Now we check Sentry's release health metrics, and our suspicions are confirmed. This is not some legacy issue that's been lurking around for months. Sentry detected a regression. This specific error started with release version 2.4.1, which, as it turns out, was deployed exactly 2 days ago.
Bridging the gap between support and dev is practically instant here. We link the Sentry issue directly to the dev team, and because of that suspect commit engine, it's auto-assigned to the author of the commit that broke the checkout. Just like that, our mean time to resolution drops to under 5 minutes. We bypass the usual back and forth entirely.
So that brings us to the end of our investigation. I want to leave you with this final thought. When your next support ticket comes in containing absolutely zero details, are you going to guess in the dark, or will you investigate the forensic trail? With tools like Breadcrumbs, user context, and release tracking, the evidence is already waiting for you. Thanks for joining me on this explainer, and happy debugging!